Hello, and welcome back to Homework Help for Math 2. Today we're going to be looking at Chapter 6, Trigonometry, Lesson 4, Applications of Right Triangle Trigonometry. So these problems are directly out of the book. Read out the directions here. So for questions 1, 2, and 3, they all have the same directions. Directions here say, for each story presented, sketch a picture of the situation and label as much of the picture as possible. And again, that's for 1, 2, and 3. So for number 1, scenario is, Jill put a ladder up against the house to try to reach a light that is out and needs to be changed. She knows the ladder is 10 feet long, and the distance from the base of the house to the bottom of the ladder is 4 feet. All right. So I am not an artist, at least not in this capacity. And so when I sketch scenarios like this, I keep them rather minimalist. If you want to like actually draw the house and draw the ladder and all that kind of fun stuff, as long as it doesn't distract you from getting the right answer, that's fine. But my drawings are going to be very sparse, we'll say, very minimalistic. So, and they're also not always going to be drawn to scale. I'll try to keep them to scale sort of when it's reasonable, but for some of these questions, drawing them to scale just isn't feasible, and we'll get to those in a little bit. So, I would encourage all of you to sort of visualize, what this looks like in your head. You've all seen a ladder leaning against a building, and I think it's safe to say that the house and the ground are perpendicular, right? That the house isn't like leaning or anything like that. So what we have here is we have a house, and this is the side of the house, and that's the only part. I'm not going to draw the rest of the house. I'm just drawing the part that I care about. And then we have a ladder that is leaning against the house. And then we have the ground. And we'll just finish that off. Okay. So this is my picture. And like I said, it's safe to assume that the house and the ground form a right angle. So that goes there. The vertical thing is my house, or the side of the house. The horizontal thing is the ground, and the thing that is leaning is the ladder. So that's my picture. We are also told some of the values of these things. So we know, or Jill knows, and us, everyone knows that the ladder is 10 feet long. And go ahead and underline this. The distance from the base of the house to the bottom of the ladder is 4 feet. So from here to here, the ground is 4 feet. The directions just say sketch a picture and label as much of the picture as possible. Well, we've sketched it, and I can't really think of anything else that we can label here. We don't know the height of the house, and we don't know any of our angles, and there's nothing else really going on in this problem. So that's my picture for number 1. Number 2. Francis is flying an airplane at an altitude of 3,000 feet when he begins a descent toward the ground. The plane has an angle of descent that is 15 degrees. All right, so this is going to be one of those situations where it's not really going to be drawn to scale. I don't think it's going to be drawn to scale. No, the 15 is going to make it a little bit too challenging. So I'm not going to worry about this being, to scale or not. I'm just going to draw it. So our plane is right there. That's our plane. It's a dot. I am not drawing an actual plane. And we are told that the altitude is 3,000 feet. Okay. So this right here is my altitude. And like I said, we are told that the altitude of the plane is 3,000 feet. I guess unlike number one, I'm sort of labeling and doing numbers as the things pop up. I'm not finishing out the whole sketch first and then labeling everything. Now, what is happening is the plane is descending, and so it's eventually going to hit the ground. So the plane is descending at an angle of depression. So that the line that I just drew is sort of like the flight path of the plane. So we'll call it, we'll just call it the path, flight path. Flight path. So the plane is going to go along that flight path. We don't know anything about the flight path. And then this horizontal guy is just the ground. Just like that. Finish out our triangle there. And so, yeah, I'll just label this as this is the ground. Now, altitude is how tall something is. What's the vertical distance? Well, that's going to form a right angle with the ground, right? The altitude and the ground they're perpendicular. They form a right angle. We've labeled our sides. We've labeled the 3,000 feet. So the only thing that we don't yet have in our picture is this angle of descent. And we're told that the angle of descent is 15 degrees. Now the angle of descent, got to be real careful here. An angle of descent it's always off of the horizontal, right? So the plane, I'll do it in red. The plane is right there. The plane is right there. And an angle of descent or an angle of elevation is always off of a horizontal line. And then, this kind of just continues on forever. Okay? So the angle of descent, it's going down. So that means that off of the horizontal, I go down 15 degrees right there. And this angle right there is 15 degrees. That is what the angle of descent looks like. Again, you start on the horizontal, which is this incomplete line there. And if it's an angle of descent, you go down towards the ground. If it's an angle of elevation, you go up towards the sky or whatever. But that's where the angle of descent is located, is right in that spot right here. And you really want to make sure that it's in the correct spot, because if you put it in the wrong spot, there's a decent chance that you might get it wrong. You might get lucky and still get it right, but you don't want to rely on luck. You want to put it in the correct spot. That is my angle of descent, and that is my picture. And we are good to go. There's a little bit more to add to this picture, but we'll revisit it in when we see this question again in question 6. Question 5 is when we'll add a little bit more to this picture. But for now, this is all the information that we have. Question 3. Abby is standing at the top of a very tall skyscraper and looking through a telescope at the scenery all around her. The angle of decline on the telescope says 35 degrees, and Abby knows she is 30 floors up, and each floor is 15 feet tall. All right. So my skyscraper is that guy right there, the side of the skyscraper, I guess, the side that Abby is on. And Abby's at the top. All right, so there's Abby, my red dot. Now, she's looking down. So we have an angle of decline. So just like we saw in question 2, an angle of decline is always off of the horizontal. So you need sort of a placeholder horizontal line there. And it says that the angle of decline is 35 degrees. Okay, so we'll just go ahead, sketch it like that. Again, I'm not too worried about this being to scale. I just want to try to get my picture set up here. And again, the angle of decline, you start at the horizontal and it's decline, so you go down. And so we're going to start here and go down like that. And that angle is 35 degrees. Great. We know, well, it's probably safe to guess that we should probably just finish out the triangle. It doesn't really, this question doesn't talk about the ground, but like, I would not leave your triangle incomplete. I would just go ahead and just finish it out just like that. All right, like I said, this guy on the left is our skyscraper. Okay. Our hypotenuse here isn't really, it's the line of sight, I guess. This is her line of sight. If you're in Spalding, go check in with Stukes. Clearly forgot to turn off Teams. And then at the bottom here is the ground. All right, the only other thing to add to this picture here, as of right now, is this whole business about her being 30 floors up and each floor being 15 feet tall. All right, well, all I really am going to care about is the height of the skyscraper, right? I just want like one number that just tells me, all right, in feet, how tall is this skyscraper, right? So it's all good and well that we know that there's 30 floors up and each floor is 15 feet tall, but I want to sort of condense that down to a single number that would give me the height of the skyscraper, because that seems like useful information. Well, if she's 30 floors up and each floor is 15 feet tall, if I want my total height, well, I take each of the 30 floors and I'm going to multiply each floor by 15 feet. Each one's 15, and there's 30 of them, so my total height is going to be 30 times 15, which is 450 feet. So my skyscraper here is 450 feet tall. And I believe that has all the information that we are given. I don't think there's anything else to label yet. And so, again, we're going to revisit this in question 6, and we're going to add a little bit more, but for now, I think that's fine. And that is our picture for number 3. All right, new directions. For problems 4 through 7, use the sketches you made in problems 1 through 3, or just make a new sketch, to help you find the missing values. So question number 4, this piece of number 4, right there in brackets, is identical to question number 1, right? That's the scenario. So it's the same exact scenario. Now, because I'm doing this digitally, I can like cheat a little bit, I guess. And I can actually, let's see if this is actually going to work. Can I do this? Awesome. We're going to copy that. Cool, cool. And we're going to put it here. Paste. Oh, it's up there. I don't want it up there. Oh, come on. Don't make this difficult for me. We're going to try this one more time. See if I can get this to actually work. Paste it right there. Paste. You are being difficult, but can I move it? I can. There we go. Awesome. All right. There is my, come on. There's my picture from number 1. Now, in your book, you can't just like copy and paste like I did, so you might have to redraw the picture. So sorry about that, but you should refer to the picture. Do not try to answer this question without drawing a picture. That's bad, right? So either flip back to 1 or just copy it over, but you definitely don't want to do this blind. You want to make sure that you're looking at a picture that represents the scenario. All right. So like I said, in red, the part in red in the red bracket doesn't change, but now there's 2 questions that have been appended to this description. First question says, how high does the ladder reach up on the side of the house? How high does the ladder reach? Okay. So in our picture, that is represented by my vertical distance, h. How high does the ladder reach up? So my height. Our second question is what is the angle of elevation formed by the ladder in the ground? All right, we're going to ignore that for a second. Let's just answer the first question, then we'll deal with the second one. So the first question again, how high does the ladder reach up? That is my value for h. It is the vertical distance up the house where my tip of the ladder, which is right there, meets the house, right? How high up does it reach? Notice that we know that our answer has to be less than 10. In a geometric context, 10 is the hypotenuse, and the hypotenuse is the longest side. But also, if you think about a real-world context, well, the ladder is 10 feet. So there's no way, if it's leaning, it could be higher than 10 feet. That doesn't make any sense, right? So whether you see that geometrically or you just put on, your thinking cap and just think, just use your common sense here, there's no way that the ladder is going to reach 10 feet if it's leaning, right? 10 is sort of its maximum, and that's if it's like standing straight up. So h has to be less than 10. All right, so what we have here is we have a right triangle where we know two of our sides and we are missing our third side. We've now seen this many times, and I hope that most, if not all of you, are getting comfortable recognizing that this is a scenario where we want to use the Pythagorean theorem. We know two sides of a right triangle. You want to solve for the third side. Whenever you see that, alarm bell should go off, Pythagorean theorem. So, as always, Pythagorean theorem says that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. In this picture, one of our legs is 4. It does not matter which one you make A and B, right? So that never matters in the Pythagorean theorem, right? A and B are your legs, are your legs, are your legs, and you can put them in either order. So I've decided that A is going to be 4, so it's 4 squared. Plus, I'm using h to represent the height. If you used b or really like any other just about any other letter, it's fine. But I'm using h to remind me that we're finding the height. And then that's going to equal 10 squared. All right, all I got to do is get h by itself, and I've answered the question. This next step is not strictly necessary, but I find it helpful sometimes to actually just evaluate the squareds. Technically, you don't need to do that, but I think it's easier if you can just get rid of those squareds at least. We're trying to get h by itself, so the first thing we got to do is we got to get rid of that 16. And so h squared, 100 take away 16 is 84. I don't want the squared, I want just h, so I take the square root of both sides. So h equals. I do not need a plus minus here because we're talking about a real world situation, and the house does not go underground. It does not have a negative height. So even though I quote normally would need a plus minus when I take the square root like this, because this is a real world scenario where negative answers don't make sense, I am not going to put a plus minus, and I'm going to leave it as just the square root of 84. If your class is simplifying square roots, well, you can rewrite this as 4 times 21, and the square root of 4 is 2 root 21. So depending on sort of what your teacher is looking for, I would say if you want to give an exact answer, you should either say the square root of 84 or 2 root 21. Those are both exact answers, and 2 root 21 is a little bit better because it's simplified. But if you're not simplifying square roots, then you would leave it as the square root of 84. The other thing to note here, however, is that, again, this is a real-world scenario. And whether you say the square root of 84 or 2 root 21, you're not going to do that in like, if you get like a tape measure and you actually measure the height, you're going to get a decimal, right? You're not going to leave it as an exact answer here. So in a lot of real-world scenarios, even if the directions don't say to approximate your answer, it's probably a good bet that you should, because again, if you're trying to find the height of the house, the square root of 84 isn't like particularly useful information, right? Like what even is that, right? It's a little bit more than 9. So I would recommend in this problem to actually find the square root of 84 or 2 root 21. And directions don't say what to round to, so we'll just say that our height is approximately 9.2 feet. Just like that. If you rounded to the nearest foot, it would be 9. If you rounded the nearest hundredth, it's 9.17. but sort of my default is just to the 10th. I think that's fine. So I would not leave your answer as exact for this problem. I do think that it's a good idea to round just so that you, like 9.2 feet is a lot easier to sort of work with and visualize than the square root of 84 feet. All right, we are not done. So please don't make the mistake of forgetting that there was a second question that was asked. Second question is, what is the angle of elevation formed by the ladder and the ground? All right, well, they tell you that we're looking for the angle that is between the ladder and the ground. All right, well, the ladder is here and the ground is here, so the angle that's between them is right there. So even if you were a little tripped up by this whole angle of elevation, just by reading the directions, they're looking for the angle formed by the ladder and the ground, and that's called an angle of elevation. So again, even if you didn't know what an angle of elevation was, just find the angle between the ladder and the ground, which I've indicated in my picture there. I'm going to use the Greek letter theta to represent my angle, and I'll draw it a little bit bigger. It's like a zero, but with a line through it. Sometimes it's fancy and it's like a little slanted, like that, I guess, whatever. If you're not familiar with that symbol, you're going to want to get familiar because this isn't going to go away. Theta is commonly used to represent angles in all of math, algebra, geometry, calc, everything, right? So theta is commonly used for angles, and so if you're not in the habit of using theta to represent angles, it's not a bad habit to get into because whether you like it or not, you're going to see it a lot, so you might as well start using it now, just as a mathematical convention. Having said that, you could use any letter that you want other than the letter that you used for the height. So we're trying to find theta. And if I look at my triangle here, well, I have a right triangle. I know two sides. I'm looking for one of my acute angles. This is a scenario where you guys have, we saw this in the previous lesson. This is where we want to eventually use inverse trig. Okay, we're going to use inverse trig to solve for our angle theta. And so I'm going to label my triangle yet again. This time I'm going to label it relative to theta. Right? I want to label opposite, adjacent, and hypotenuse relative to theta. I recommend you start with the hypotenuse. The hypotenuse is the ladder. Opposite is the house. And adjacent is the ground. Now, what I want is I want to know, all right, of these three things, what do I have some values for, right? How long are the things that I can use here? So notice that I'll just circle everything. The hypotenuse, which is the ladder, which is 10 feet, we know that. And we know that the ground, which is adjacent, is 4 feet. So thinking about this, we've circled the hypotenuse and we've circled adjacent. And we want to know, all right, well, which trig function connects those two things? As always, if you have not yet memorized the definitions for sine, cosine, and tangent in a right triangle, you can always fall back on so, ca, toa. It's kind of a handy thing to remember the definitions. All right. So ca is cosine, and you can see here that ca, so the c is cosine, the a is adjacent, and the h is the hypotenuse. Meanwhile, for sine, it's opposite over hypotenuse, and for tangent, it's opposite over adjacent. So the trig function that deals with both hypotenuse and adjacent is cosine. And you need to be able to figure that out, right? Your teacher's not going to be able to tell you on an assessment, oh, use cosine. You have to recognize, oh, I have to use cosine because I know the adjacent, I know the hypotenuse. That's what cosine deals with. So cosine of my angle, right? Trig functions are always of angles. Cosine of my angle, at least in this class, they're always of angles. Cosine of my angle is adjacent, which is 4, and my hypotenuse, which is 10. That simplifies to 2/5, but I wouldn't recommend doing it because you're just going to go to the calculator anyway, and why set yourself up to make a careless mistake? All right, I want to get theta by itself. Now, I've heard some students refer to multiplication in this context, as in like it's cosine times theta. I see what you're saying, but it doesn't work that way, right? There's no multiplication in this equation, right? Cosine is a function, and you are applying the cosine function to theta. Um, if you want to think of it as multiplication, like, all right, well, you say, oh, what's the opposite of multiplication? The opposite of multiplication is division. So to undo multiplication, you divide. This is not multiplication. This is the cosine function, which is different. But you still want to get theta by itself. And you say, all right, well, how do I get something by itself? And we use inverse operations. To get rid of multiplication, use division. To get rid of addition, use subtraction. To get rid of a squared, you use a square root, right? The inverse of cosine doesn't really have a special name. It's just the inverse of cosine, or I say cosine inverse. That might be wrong, but I don't care. I've been saying it for years and years. I'm not going to change. So, cosine inverse. The whole point here is that what happens on the left is you have an inverse trig function, and then you have the original trig function. So they cancel, and on the left you have just theta, and that's great because that's what I want. When you apply the inverse trig function on the left, you have to also apply it on the right. So cosine inverse of 4/10. That is my answer. That's my exact answer. But again, especially now, it really doesn't make sense to leave this as an exact answer. You really should go to your calculator and you should evaluate this. So I'm gonna bring up mine. All right, now, as I've said a couple times, if you do not reset your calculator and if you do not change the mode, and if you previously set your calculator in degree mode, it should, quote, should still be in degree mode. I've sort of deliberately reset my calculator, so you'll notice that up here at the top, mine says radian. If you have a calculator where it tells you the mode, then just double check and make sure that it says degree. If you don't have a calculator that has this information at the top, you really should press mode and confirm that degree is highlighted, okay? So mine, like I said, is not. Yours probably is, but you want to just double check. So if degree is not highlighted, you have to go over to it, press enter. Now I want to get out of this screen. I get out of this screen by pressing second mode to quit. I'm back at my home screen. And what I want is I want cosine inverse of 4/10, or 0.4 would also work. And I get, again, the directions didn't really say what to round to. So if you said 66 degrees, that's fine. 66.42 is a bit extra. I just by default sort of round to the nearest tenth. So I'm going to say 66.4. So theta is approximately 66.4 degrees. Now, if I were really being an excellent homework helper video maker guy, I would actually write out in like full sentences. I would write out like the answers to the questions. So it says, how high does the ladder reach up on the side of the ground? I would write, the ladder reaches up 9.2 feet up the house. And what's the angle of elevation formed by the ladder on the ground? The angle of elevation formed by the ladder on the ground is 66.4 degrees. I don't feel like doing that, and I don't feel like subjecting you to my terrible handwriting and writing that all out. If you do write it out, you'll probably make your teacher happy because it just means that you're really like invested in giving like a really great answer. However, I think that just leaving the answers sort of the way that they are is probably sufficient. So the ladder reaches up 9.2 feet, approximately 9.2 feet, and the angle of elevation is 66.4 degrees, and that is question 4. Question 5. So question 5, the part in, well, I don't know how much was given. Oh yeah, there's not. So this part right here kind of will stop like mid-sentence. That is just about identical, has the same information as question number 2. And again, I'm going to cheat here a little bit, and I'm going to literally use the whole copy-paste functionality because I'm doing this digitally. If you're doing this by hand, which I imagine just about all of you are, what am I looking for here? I am going to copy. I think that worked. and it's going to put it at the top of the page, which is kind of annoying. Or is it? Oh, come on. All right, I'm going to try this one more time, see if it works. I could just draw it again. If it doesn't work this time, I will redraw it. Copy. All right. Or I guess I could just move it as well. Paste. Come on, did that? I don't know what, it just went away. What's going on here? Paste. There it is. And we're going to move it down. Moving, moving, moving. Sorry, technical difficulties. All right, come on. Moving, moving, moving. Clearly should have done this ahead of time. All right. I'll adjust the timestamps so that question 4 starts. All right. All right, question 5 starts now. So we're just going to ignore everything that just happened. Question 5, the part that's in the red bracket is just about identical to question number 2. And after a whole lot of technical difficulties, I eventually was able to get my original sketch here again. If you're working the book, I guess you kind of just have to sketch it a second time, which isn't the worst thing in the world. But you definitely want to refer to the picture. Don't try to do this without a picture. So again, as a reminder, Francis is flying an airplane 3,000 feet. He begins a descent. If the angle of descent is 15, how far, this is our question, how far will the plane travel through the air before it is on the ground? That's what we're being asked to find. So that is our flight path, which I'll just label as X. You could use just about any letter that you want. I'll just go with a standby and just say it's X. Now, there are 2 different but ultimately equivalent ways of tackling a problem like this. And you will almost certainly see a problem like this on both the unit assessment and the final. So you want to know how to handle it. You do not have to use both methods, and I think I speak for all of the math department when I say that we don't really care which method you use, I think, but check with your teacher, see if they have a preference. I think that the book, I'll describe it the way that I think the book talks about it, and then I'll show you a second method that gives you the same answer. So, as you may have seen in the lesson, the angle of elevation, which I have highlighted there, is 15, has a very special relationship with, I thought that was highlighted, has a very special relationship with this angle right here, okay? That angle right there. This angle is the angle of elevation. So an angle of depression and an angle of elevation, they're always off of the horizontal. The angle of elevation goes up, and the angle of descent goes down. You may notice that both the ground and this horizontal line up top, those are parallel, which means we have a parallel line, or sorry, 2 parallel lines right there in green that are cut by a transversal in red, just like that. So what that means is this angle here, and this angle here, these angles are what are called alternate interior angles. They're alternate because they're on different sides of the transversal. They're interior because they're on the inside of this figure here. The outside is like this area and like this area, right? So they're alternate and they're interior, so they're alternate interior angles. And alternate interior angles are congruent. They have equal measures. So what that means is if the angle up top is 15, if the angle of descent is 15, it means that the angle of elevation down here has to also be 15. Because again, my green lines are parallel They're both horizontal lines, and then the flight path is my transversal. So that means that they're alternate interior, which means they're congruent. So that means that the angle at the bottom is also 15. The reason why that's helpful is that now I have a right triangle where I know one of my sides, I know one of my acute angles, and I am solving for another side. You cannot use the Pythagorean theorem in this context, because in order to use the Pythagorean theorem, you must know two sides. The only side that we know is the altitude. We don't know the ground, and we don't know the flight path. So you can't use a squared plus b squared equals c squared. We have to use trigonometry. So what we're going to do is we are going to label the three sides of our right triangle, and we're going to label them relative to the angle that we know, which is 15 degrees. So if the 15 is there, it means that the flight path is the hypotenuse, it means that the altitude is opposite, and it means that the ground is adjacent. What I want is I want to use whatever trig function, sine, cosine, or tangent. I want to use the one that connects the thing that I know, which is the 3,000 feet opposite, and the thing that I want to know, which I've labeled as x, which is the hypotenuse. So which trig function, sine, cosine, or tangent, connects the opposite and the hypotenuse? If you don't know, I would pause the video, because you have to know that. You have to be able to do this, right? So if you're watching the video and you don't know what to do, take a guess. Is it sine, cosine, or tangent that connects opposite and hypotenuse? Take a second. And hopefully you were able to realize that the trig function that deals with opposite and hypotenuse is sine. So sine of my angle, trig functions, again, they're always of an angle in this class. So sine of 15 degrees. Sine is opposite, which in this case is 3,000. And hypotenuse I've labeled as x. And now I want to get x by itself. Well, before I get x by itself, x is in the denominator. So I got to fix that. I don't want the thing that I'm solving for to be in the denominator. It's going to make things complicated. So let's multiply everything by x. So that gives me x sine of 15 equals 3,000. Okay, well, we've made progress because x is now out of the denominator, but it's still not by itself. So to get x by itself, I'm going to divide everything by sine of 15. So on the left, my sine of 15s cancel, and I'm left with just x equals. That's great. That's what I want. And on the right-hand side, we've got 3,000 divided by the sine of 15 degrees. That's my exact answer, but I would strongly recommend that you not leave it as an exact answer, that you should get an approximate answer. So to get my approximate answer, we are going to say 3,000 divided by sine, not sine inverse, right? It's just sine of your angle, and your angle here was 15, close parentheses. And we end up getting 11,591.1. The directions didn't say what to round to or whether to round at all, but I'm just going to decide we're rounding the nearest tenth. So this is approximately 11,591.1 feet. I guess if this was a science class, we would probably be using significant figures. But this is not a science class, it's a math class, so we're not really worried about significant figures, at least not in this particular class. Maybe in some other math classes we would. But yeah, there's only two significant figures, so we'd have to round this to like 12,000 feet, and that seems like a big round. So we're just going to flat out round to the nearest tenth. And that is how far the plane travels through the air. Now, that's my answer. And if that answer is good for you and you're good and you want to move on, go ahead and move on to question 6. That's fine. I'll be there in just a minute. If you're looking for an alternative way to solve this problem, an alternative way, I'm going to get rid of all this. We don't need the alternate. Oh, shoot. We do need flight path. Okay, but we don't need that. We don't need that. That's all going to go away. Get rid of that. Get rid of that. And get rid of that. All right, so if you're looking for just an alternative way to solve this problem, And again, this is extra, so feel free to skip if you want. But this angle up here is a right angle, right? So the line of the horizontal and the vertical line, those form 90 degrees. And if my angle of descent is 15, it means that this angle here has to be 90 minus 15. Because together, those two angles have to form a 90-degree angle, which is 75. So this angle right there has to be 75 degrees. Notice that when we got our angle of elevation earlier, that was 15, and the acute angles of a right triangle sum to 90, because together with the right angle, they have to sum to 180. And 75 plus 15 is, in fact, 90. But the whole point here is that if you wanted to, you could solve this question without ever getting the 15 down there, because now what we have is we have a right triangle where we know one of our sides, one of our acute angles, and we're looking for the another side. So okay. So if I label my right triangle relative to the 75, the flight path, that's still the hypotenuse, right? That doesn't change. However, now that we're talking about the 75, well, now the ground is opposite and the altitude is adjacent. And so now I want to say, all right, well, what's the trig function that connects what I know with what I want to know? And that's adjacent and hypotenuse. So if I want to solve this a separate way, I can say that the cosine, and we're dealing with cosine because, again, that we're dealing with adjacent and hypotenuse this time. So the cosine of my angle, which in this case is 75, is going to be adjacent, which is 3,000, over my hypotenuse, which is x. So this certainly looks similar to the last question, or the first way that we did this. Multiply by x, x times cosine 75 is 3,000. Divide by cosine 75. That goes away. And so x is exactly 3,000 divided by cosine of 75. And when you type that into your calculator, I'm not going to show it just because I want to move on here. I'm not going to show it. But when you type that in, you get the same exact 11,591.1 feet that we got before. And we better get the same answer because both methods are perfectly valid. So again, I think the lesson went over the first way, and if that way makes sense to you, then that's great. But I did also want to point out the second way because it's really not that bad. You just have to recognize that the angle at the top is a 90-degree angle, and so the angle of descent along with the other angle have to sum to 90, so that's 75, and then you're just kind of off to the races and you just solve, and you get the same answer that we got before. And that's question 5. All right, that was way more complicated than it had to be, but point is we got our picture and we're all set to go now with question 6. So question 6 is more or less, the beginning is more or less identical to question number 3, same scenario. So Abby's standing on top of a skyscraper looking down, angle of decline. We figured out in question 3 that the skyscraper was 450 feet tall. So that's all the red bracket. The question that we're now being asked to find is, how far from the base of the building is the object that Abby is looking at? All right, so we've got our picture, and like I said, it says how far from the base of the building is the object that Abby is looking at. So that means that we are looking for this value here, because the object is here, and the base of the building is here, and so how far apart they are is going to be represented by x, the distance along the ground. All right, well, we have a right triangle here, and we know one of our sides. We want the other side, but we don't have either of our acute angles. In question 5, I went into more detail about how to get one of those acute angles. So if you haven't seen the video for 5, I would actually go and watch 5 first, because 6 I'm going to do a lot quicker. 6 I'm just going to flat out say that, as you saw in the lesson, this angle of descent, 35, is the same thing as this angle of elevation right there. So this angle is also 35. The reason is because of parallel lines and transversals and their alternate interior, yada, yada, yada. If you want a more detailed explanation, check out question 5. That's where I go into more detail. So we now have one of our acute angles, which means we cannot use the Pythagorean theorem. You can only use the Pythagorean theorem when you know two sides and you're looking for the third side. In this picture, we only know one of our sides. So you cannot use a squared plus b squared plus c squared, or equals c squared. You have to use trig. And the trig that we're going to use, it's going to be relative to angle 35. I'll get rid of that circle. Okay, so it's relative to the angle that I've circled. So the line of sight is my hypotenuse. The 450 skyscraper is opposite, and the ground is adjacent. So I know my opposite, and I want my adjacent. So you say to yourself, all right, which trig function, sine, cosine, or tangent, connects opposite and adjacent? And the answer to that question is tangent. And yes, you are expected to be able to answer that question. Your teacher cannot help you on an assessment figure out which trig function is it. You need to know the definitions, and you need to be able to apply them in this scenario and know that in this question you need to use tangent. So, tangent of my angle is 35 degrees. Now the definition for tangent is opposite, which in this case is 450, over adjacent, which I've labeled as x. We want to get our unknown by itself, so x times tangent of 35 equals 450. That gets it out of the denominator. We want to divide by tangent of 35. We're dividing because x is being multiplied by the tangent of 35. So to undo multiplication, you use division. So x equals 450 divided by the tangent of 35. So we'll go ahead and type that in. We want the tangent, oh no, sorry, we want 450 divided by the tangent of 35 degrees. And again, our convention here is just we're rounding to the nearest tenth. So this is 642.7. This is not 0.6 repeating, right? It's 0.6666, but then the 0.3 means it's just a random number, right? So this is 642.7. If you round to the nearest whole foot, it's 643. So, yep. X is approximately, we said 642.7 feet. Okay. And that is my answer. If you want to go ahead and skip to question 7 now, feel free. But I'm also going to do this next part. I'm going to do is a little extra. I'm going to do, again, relatively quickly. As we saw in question 5, there is an alternative way to solve a question like this. Both are fine. Try this again. Get rid of that. Get rid of that. Okay. Get rid of that. Get rid of that. Get rid of that. Okay. You can also solve this question without dealing with the angle of elevation, and you can recognize that this angle here is 90 degrees, which means this angle here has to be 90 minus 35, and 90 minus 35 is 55, so this angle is 55 degrees. And now if you wanted to, you could now solve the triangle using that angle as a reference. So just to be clear, we are using the 55 now. The line of sight is still the hypotenuse. The ground is now the opposite. The 450 is the adjacent. And so again, this is just extra. I want to connect adjacent with opposite, which means we're still going to use tangent. So tangent, this time it's 55, equals. The definition for tangent is opposite, which in this case is x, over adjacent, which is 450. All right, the definition doesn't change. It's opposite over adjacent. And now, to get x by itself, I just multiply everything by 450. So x is 450 times the tangent of 55. And if you type that in, you will get the same 642.7 that we got using our other method. So either method's fine. Use whichever one you want. No matter what you get 642.7 feet. All right. Question 7. Question 7. This, we do not have a pre-existing picture for this, so we have to draw it now for the first time. A 6-foot-tall person is standing 60 feet away from a skyscraper, looking up at the top of the building and wondering how tall the skyscraper is. Maybe he's looking at Abby from question 6. The angle of elevation for the person's line of sight is 70 degrees. Determine the height of the building. I guess it's not Abby because we knew the height of hers was 450. So you definitely want to sketch this. Now, this question is a little tricky, little wrinkle to this problem. And if you miss the wrinkle, don't feel bad because you can still do most of this question correct. But there is just a little tiny thing here. So we've got this guy, person, whatever, and there they are. Right? That's my person. Right? Again, I'm not an artist. I'm just drawing, right, literally a stick figure without the head and the appendages. That's my person. The person is 6 feet tall. Now, they are standing 60 feet away. So that's 60 feet. They are standing 60 feet away from a skyscraper. And this is not drawn to scale. Okay. So this is the ground. This is the person. This is the skyscraper. Skyscraper. All right, and this guy is looking up at the top of the building. The top of the building is here. And wondering how tall the skyscraper is. The angle of elevation for the person's line of sight is 70 degrees. So, the angle of elevation from the person's line of sight, well, the person's line of sight is at the, their eyes, which is at the top of their head, practically. So really, I mean, yes, I know it says 6 foot tall and the eyes are not at the very top of the head, but we're going to just kind of round a little bit here. The line of sight is from the top of the person to the top of the building. Right? So technically, our picture actually kind of looks like this. It's almost like a right triangle. It's almost a right triangle. It's actually a trapezoid. It's almost a right triangle. It's just like it's got like this little extra piece caused by the 6 foot tall person. And again, that's the wrinkle to this problem. And it makes it just a little bit more challenging, but it only makes it challenging like at the very end. So if this whole 6 foot tall person is kind of messing you up, you can kind of safely ignore it for now. This piece is 6, and this piece is 60. All right, so we got like this rectangle. You can safely ignore like the rectangle and just deal with the right triangle for now. Like that's a right angle. This is also a right angle. Because we know that the angle of elevation is 70 degrees from their line of sight. So that goes right there. And again, this is the person's line of sight. All right. I think that's all the information that we are given. The question, determine the height of the building. Okay. So, I am going to label as X. I'm going to label this side of the right triangle, okay? Which, notice, is most of the skyscraper. Most of the skyscraper is represented by X. I'm going to solve for X. So looking at the right triangle, what I have, again, is I have a right triangle. I know one of my sides. I know one of my acute angles, and I'm solving for another side. In order to do this, we need to use trigonometry. So I'm going to use my 70 degrees. I'm going to label my triangle relative to the 70. My line of sight is the hypotenuse. X is the opposite, and the 60 is the adjacent. I know the adjacent. I want to know the opposite. So which trig function, sine, cosine, or tangent, connects opposite and adjacent? And the answer to that question is tangent. Because the definition for tangent is opposite over adjacent. So the tangent of my angle, which is 70 degrees, equals opposite, which is x, over adjacent, which is 60. I want to get x by itself, so I multiply everything by 60. So, and I flip it around. So x equals, put 60 out front, tangent of 70 degrees. And when I type that in, I get 60 tan of 70. And I end up getting 164.8. So x is approximately 164.8 feet. And if that's what you got as your final answer, you did most of this problem correct. You did like the hard part correct, in fact. The wrinkle is the fact that the person is 6 feet tall, and the line of sight was, essentially 6 feet above the ground, maybe a little short, but only a couple inches. So the height of the skyscraper is not x. The height of the skyscraper is x plus the original 6 feet, which is this piece right here. X only went from here to here, right? That's x. But then there's an additional 6 feet. So if I want my height, I got to take x, which is 164.8, and I got to slap another 6 feet on there, bringing me now to a total height of 170.8 feet, and that is my answer. So like I said, if you missed the wrinkle, don't feel bad. The actual math part of it, you just add 6, so that's not that hard. But it's easy to miss. And again, if you got 164.8, it means you did the trig correctly. But just be aware that in the future, you do want to account for the fact that the line of sight, in this case, was about 6 feet off the ground. So that's why our final answer is 170.8. That's question 7.